Okay, dear participants, welcome to the panel session of 6th Incohis 2025 Spring Congress. Thank you for taking the time to join us today, despite your busy schedule. This Congress provides a valuable platform to share our knowledge and experience and to foster new collaborations. Your contributions will certainly enrich and enhance the quality of this panel. Today we will discuss current topics and key developments in our field. I hope this panel will help us develop new perspectives and inspire innovative ideas and stories. Okay, I would like to invite dear Prof. Erpner Ajaziti from Kosovo.
Thank you for
Dear
introduction,
Prof,
Professor Mustafa.
thank
May
you
I
very
start
much.
first?
You can
Is it
share.
now
Okay.
okay? Can you
Yes.
see the
Yes.
presentation?
Yes, we can see.
Okay. I will go like this. I don't want to increase, the presentation. So thank you, first of all, Professor Mustafa, giving me the opportunity to be the first presenter of Incohis 2025 spring session. I'm gonna give a short introduction to the paper titled Optimization of the Glass Processing Workflow of CNC Machine, Computer Numerical Control Machine. So in the second slide, here is the content of the paper that contains the introduction, description of CNC machine, including hardware and software, product definition. In this case, it is about the glass production, product processing from first to final phase, design creation and tool assignment following modification of the machine's operating parameters. After experiments that we have carried out here in our laboratories and also in the industry, we have some discussions about the obtained results, and the result we already commented, and finally we had the conclusions of the paper. For introduction, I'm not going to read all the text here, but I just want to address what we did with this paper. We did the optimization of the glass machining process using CNC technology that's of new days, where such processes are essential and indispensable in the field of glass processing. Through a combination of theoretical analysis, experimental validation, and practical implementation, this research aims to enhance the efficiency, accuracy, and productivity of CNC-based glass machining operations. And further, the study investigates advancement machining parameters, tool selection criteria, and process optimization techniques to achieve superior surface quality and dimensional precision. The findings of this research not only contribute to the advancement of the CNC machining practices within the glass industry, but also provide valuable insights and guidelines for manufacturers, engineers, and researchers aiming to optimize CNC processes for precision glass fabrication. Here you can see two pictures with regard to hardware. There is a big factory that is producing the glasses for international cooperation companies. So here is in the first picture, you can see the Intermac Master 45.5 that you can process a big place. You can see here also the dimensions of it. So there are two pictures. I'm gonna continue. We have been focused on the operation of these machines. So this machine contains 5 axes: X-axis, Y, Z axis and C axis. Each of them is playing. So we can see that this is a kind of manipulator, robot manipulator. Further, if we talk about the hardware, this is also the connecting part of hardware is the software, you know. So the machine control panel commands are given in this slide. For each, button, there is a certain command that you can activate, different actions. Further, there is a teaching pendant or so-called handheld pendant. So you can the commands do it manually, and afterwards you can memorize all those commands, you know. So it depends on the what you are gonna process. In this case, the glass. Further, we continued with product definition. So if we talk about the glass is a hard material created by heating a mixture of silicon dioxide, soda ash, and lime at high temperature until it melts, and then rapidly cooling it. So the properties are given here of the glass: its transparency, brightness, formability, and chemical resistance. In this slide, you can see the process of the cutting. So we start with the cutting process, grinding and polishing, tempering, and glass laminating until we obtain the product, the final product. Product processing from the first to the final phase is described in this slide. So execution of the machining process using the machine's existing condition, so without modification of operating parameters. So what we have done here, that is that all what the processes of doing the final, going to the final phase is already known in advance. So we just have given the parameters to the machine, CNC machine type Intermac Master 45.5. So when we talk about the machine software for creating glass, we use ICAM 2D, 2 dimensions. So you know that the glass is plate, you know, X and Y. So further, the machining program generated an ICAM, and it is loaded and selected to the machine interface. And the verification process is conducted to confirm the correctness and suitability of the tools assigned during the ICAM programming phase. And operator that specifies the glass thickness along with the total quality of material to be processed, ensuring the machine parameters are properly set for accurate and efficient operation. Further placement of stops and vacuum holders was also the part of the process. Initiation of the machining process according to the sequence of tools assigned in ICAM. So this is already, software that is used for operation. And also everything has been defined into this, software interface. The processing time for this operation is 10 minutes and 30 seconds. Further, we design creation and tool assignment following modification of the machine operating parameters. So creation of sequences in the design process for glass machining, where the following improvements have been achieved after this change. So what was our purpose? Just to reduce the time, machining time to obtain but to keep the quality as it can be done with with the older methods. So another modification made involves the repositioning of tools in the tool magazine. So previously the surface grinder and beveling tool were located in the linear magazine at position number 6. They have been relocated to the rotary or revolving magazine position number 37. So by doing this, changes, we have obtained some results that influence it in efficiency and minimizing downtime during operation. In this slide, you can see, I think, the creation of sequences in the design process for glass machining, where the following improvements have been achieved after this change. So we did the changes, and we update some results and the processing time for the operation before and after grouping into the set is illustrated through diagrams. The reduction in design creation time expressed a percentage that is 20%, indicating a significant improvement in workflow efficiency. And before implementing the tool sequences, 48 designs were produced during an hour. And after change, we obtained 60 designs. So the improvement is 25 increase or is on productivity. Here you can see some diagrams, the design processing time in ICOM. You have two bars. A left bar deals with tool selection one by one, and the right bar tools when we did the grouping. On the second diagram, you can see the tool selection one by one and tool grouping, but you see within 8 hours or one work shift. Here you can see two other diagrams with regard to operation completion time and within one shift of 8 hours. This is our original work. So here is the algorithm, step-by-step process of machining a glass piece. I'm not going to describe in details. On the right side, you can see the machine and also the glass that have been cut. You see the cycle in the middle of the glass. From the results that we obtained, you can see here some improvements regard of technical analysis of the optimization of the glass processing workflow in this machine. We achieved optimization, so you can see that reduction of approximately 2 minutes. It's maybe not so long time, but when we talk about one shift, we can, obtain too much time. Minimization of, is worth to mention, minimization of human errors, increase efficiency, and so on. What we have achieved other, advantages is optimization through tool position rearrangement in the tool depth. I'm not gonna describe in detail, but here is also we have got some, improvements. And so here is the table that contains before optimization, after optimization, and improvement with regard to program preparation time, number of designs in 8 hours, processing time on the machine, and number of glass units processed, the increasement of, after optimization. As a conclusion, with the implementation of this optimization, we can conclude that the productivity increased through time saving in two critical phases: program preparation and physical machining. Human error was reduced during tool setup and programming. Tool management improvement by assigning tool position according to the usage frequency, and CNC machine efficiency increased, making the processing cycle faster and more consistent. All testing were conducted under real working conditions using this kind of machine, as I mentioned before, and the obtained results are considered stable and suitable for industrial application. This was a short presentation. Thank you for your attention, and if you have questions, I am ready to answer. Thank you.
Okay, thank you, dear professor. Thank you thank you very much for insightful and engaging presentation. If you want, let's do the question part now.
Yes.
Yes. Are there any questions or comments from the participants? Okay, I have one question, dear Prof.
Yes, please.
How does this study aim to improve CNC-based glass machine operations? Use with short terms, only short terms. Okay.
Yeah, it's short time, and also you can see on the last slide in conclusion, you can see here efficiency is increased, so tool management is improved, and human error was because before we use this, before has not been used, we had also the human errors that indicated into the quality of the product. So when you optimize this through, this algorithm, we can obtain much more, better results before and after optimization.
Okay. Thank you again. Thank you for information knowledge. Thank you again.
I
Prof,
stop
please
sharing.
close your session. Okay,
Yes.
thank you. I would like to invite dear Prof. Maria Nazar from University of Coimbra. Dear Maria, are you able?
Yes,
Okay, floor is yours. Okay.
You can see the presentation.
Yes.
Yes.
Okay.
Yes.
I just want to put. Yeah, you can see like this. Yes. Thank you very much for the invitation and the opportunity to present our research that is about valorization of cork powder waste as a sustainable alternative to synthetic dyes in the textile industry. And this study that I will present here is a small part of a big project that we had in the past, and we try to find and evaluate the potential sources of natural dyes for the textile industry among several wastes or byproducts that comes from the activity of Portuguese industry. In the last two editions of this conference, I had the opportunity to present two study cases, one with grape pomace, that is a winery waste, and another one with arbustus or needle fruit waste, and both these wastes showed a very interesting potential as natural dyes. I started my presentation presenting the motivation and objectives of this study. Then I will introduce all the methodologies that we use, the main findings, and at the end some conclusions and remarks. I start for the main objective of this work, and this is to assess if the cork powder that comes from the cork industry, and in particularly on the manufacturing of cork stoppers, is the main waste or byproduct that they get. And we want to evaluate the potential of this waste as a source of biodyes for textiles. These principles align with circular economy and sustainability principles. So I will present this as a case study of waste valorization. The cork comes from the bark of the cork oak, and these trees grows almost in the Mediterranean regions. As you can see in this table and in the graphic, Portugal is the world leader of cork oak forest. As you can see, 34% of the coverage of this kind of forest are situated in Portugal, followed by Spain with 27% and Morocco with 18%. In Portugal, these fields of cork oak tree that we call here montados, and you can see a picture in this slide of a montado. They are located essentially in the south of Portugal, in particular at the region of Alentejo, where 71.7% of the montados are located. This part of Portugal is very dry and hot in the summer, so this kind of tree develop very well in this region. The most important product of the cork sector is the cork stoppers, and in this case is the wine industry the main sector that retain the cork products. As you can see in this graphic, almost 73.5% of the products of cork goes to the wine industry to make natural cork stoppers or technical cork stoppers. Nowadays, the construction sector also have a good position with 24.1%. The raw materials that we used here in this work was obtained for a local factory, M. Silva Cortiças, and the cork powder was obtained directly from the mechanical operation of natural cork. And here it is important to say that care was taken to avoid the contamination with chemical products that usually are used in the production of technical cork stoppers or during the final phase of surface treatment. The other raw material that we use in this work, it was the fabrics, and we use two different types of fabrics: wool, organic wool, and natural cotton. These textiles were kindly provided for partnership enterprise from the north of Portugal, Intex S.A. We use also natural cotton with pre-treatment in the surface with cations that we will call cationized cotton, but for reasons of confidentiality, I cannot describe the process of cationization. The main methods started with the extraction of the biodyes or the coloring compounds, and we made a solid liquid extraction with water at two different temperatures, 30 degrees and 100 degrees at boiling stage. And we use also different amounts of cork powder, concentrations of 5 grams per liter, 10 grams per liter, and 20 grams per liter. We made these extractions under excitation during 3 hours. And during these 3 hours, we take small amounts or samples during the process every 30 minutes to evaluate the dye extraction efficiency. These samples will be later, and I will show, analyzed by spectrophotometers analysis. At the end of the extraction, the solution was filtrated under vacuum in order to obtain a clear dyeing solution. This dyeing solution was used also to evaluate the phytochemical constituents in the dyeing, and also we made antimicrobial tests to evaluate the activity against 2 bacteria, 1 gram-negative and 1 gram-positive bacteria. But in fact, the main experiment was for dyeing the textiles. We dyed the textile in triplicated during 100 minutes at 50 degrees under agitation. And I must refer that parallel to the dyeing samples, we also used a control that we call blank, that has the same steps, but instead of using dyeing solution, we used water. After the dyeing, the process of dyeing, and in order to evaluate the color fastness, we made tests of washing and also of light exposure. In the tests of washing, we made 2 steps, one with cold water at 20 degrees during 10 minutes, and after they submit the dyed samples to washing with water at 45 centigrade degree during 10 minutes. To evaluate the color fastness by light exposure, we distribute all the samples dyed in a plate, and they stayed for 1 week exposed to the natural light, with half of the surface protected with a dark curtain. After 1 week, we measured the final color in the tissues using the CELAB color system. For this CELAB color system, we measure 3 coordinates, L, A, B, that gives the lightness, red and green, blue and yellow respectively. And from these coordinates, we can calculate a parameter that we call delta E, and these parameters represents the difference between 2 colors. It means bigger parameter is representing more distant colors. We made and we calculated this parameter between the dyed sample and relative to the blank sample. The magnitude of this delta E, as I said before, represent how we can pursue the color, and I should emphasize that parameters greater than 5 means that we have two different colors. So we have this in our results. In this slide, you can see the absorption spectra of the cork powder samples solution collected during the extraction process, as I told, during each 30 minutes. As you can see, we have a great effect of the concentration of cork powder, and we will see that also about the temperature. I must refer that this set of curves of spectrum represented by red colors belongs to the more concentrated solution use of cork powder. The green ones to the intermediate concentration, and the blue represents the lower concentration used of cork powder. This slide shows similar absorption spectra, but obtained for the samples collected during the extraction carried out at 100 degrees. As main conclusions of these graphics, we can see, in fact, that the amount of cork powder used in the extraction process has a great relevance to the level of biocompounds extracted in both temperatures used in the extraction process, because as you can see, great amounts of cork powder represents great magnitude of absorbance, and also the effect of the temperature of the extraction is similar. It means higher temperatures, greater amount of biocompounds extraction. Another interesting conclusion is that we made extractions of a duration of 3 hours, but in fact, after 60 minutes is not significant, the difference with this spectra, so is not advantage to extend the extraction. As I referred before, we also measured the antimicrobial activity of the coloring solutions. Unfortunately, we observed that the extract did not inhibit the growth of the two bacteria, because they don't observe the inhibition zones after the incubation of diffusion plates. We also made phytochemical screening of the extracts, and we notice the existence of different compounds, for instance, saponins, phenolic compounds, majority of them, they were insoluble to water, flavonoids, and tannins. And usually this kind of compounds are associated with coloration and antioxidant properties. In which concern the colors, we can see in these three graphs where all the results are represented that we obtain in all the situations different colors, because if you can see, all the parameters delta E are greater than 5, and this means that when comparing the color of dyed sample with the blank, it represents a different color. This is the first conclusion that we can have from these graphics. And also, we can see that the coloration is more intense when we use cationized cotton, and this clearly shows that the incorporation of cations in the surface of the fibers of the cotton results in a better dye fixation, and so the result color is more intense. In general, also the value of delta E is greater when we use in the extraction greater amounts of cork powder, and also greater temperatures. In order to be possible to check and to observe the real colors that we obtain in the fabrics, we transformed the measured coordinates LAB to RGB coordinates, and we reproduced here in these squares the real colors. As you can see, in all the conditions used at 100 degree in the extraction or 30 degree, we have beautiful earth tones, and so this indicates that our waste can be valorized with success as a biodye. As final conclusions, I can say that these earth tones that ranging from intense brownish gray to light brown are very interesting, and they have commercial potential. Additionally, the colors obtained in the samples are very uniform, what is very good for the consistency of the results, although we must continue with our research to improve mainly the color and the fastness property. I would like to finish my presentation to say that I'm very grateful to the enterprise that were involved in this project, mainly Tintex Textile, because it supply the substracts, but also for the technical assistance. And I'm very grateful for this opportunity to share my results.
Okay, thank you very much, dear Prof. Maria. Especially your presentation was both informative and stimulating. Thank you again.
Thank you.
Okay, are there any questions or comments from you? Okay, dear Professor, I have one question.
Yes.
What is the what was the biggest difficulties in your study? Biggest difficulties.
Yes, the
Okay.
biggest difficult is not only in my study, is in all the researchers that works with natural dyes, is to fixate the color in the tissue during the light exposure. Because with natural dyes, the color of in the tissue with exposition to light, natural light, is start to fading. It means the color becomes less and less intense. And this is the great difficult. We are trying to use nanoparticles to try to improve the fixation of the dye in the tissue. Is the next step.
Okay. Thank you again. Thank you. I would like to invite Professor Desire Dizigiyama, University of Burundi, to share your thoughts out with us, Professor. Are you able?
Yes, please.
Okay. The Professor, the floor is yours.
Mhm. Do you see my flash right? Hello?
Yes.
Okay, thank you. Yes, good afternoon
Yes,
once again
it is
to
okay.
everyone. Yes, I'm going to talk about something quite different. I'm going to talk about regional integration in the East African community. And this is a research which is going on right now, but we are almost coming to some conclusions which I'm going to share with you. And the title of my presentation is Unveiling Innovative Grounds for Promoting Economic Growth and Development in East African Community using regional integration perspectives. East African Community is one of the fastest growing African regions in both its size and also its efforts towards regional integration. Research in the area of regional integration in Africa and beyond has proven that a traditional model of regional integration, which actually focused on trade, did not manage to promote economic growth and the development countries involved. But there is an argument here that the regional integration remains one of the key strategies of promoting economic growth and the development in African countries. There is therefore a need to investigate modalities and the values of regionalism, which would be able to offer adequate conditions for African countries to realize their potential in terms of economic growth and development. And then I took East African community as a case study to analyze and evaluate the values and the modalities of regionalism, which would promote economic growth and development within East African community member states. My analysis then focuses on two areas. First, there is the area of cooperation arrangements and the area also of institutional values. And this is what the element which can help to help East African community to be an economically strong and integrated region. And then in the end, I make some suggestions on what would be the potential contributions of East African community partner state, like partners from outside, in promoting economic growth and development of this region. For those who may not know, East African community is East African community is made It's made of 8 countries. Do you hear me?
Your presentation is closed. It's flowing.
hear
Yeah.
me?
Yeah.
Okay,
No
thank
problem.
you.
Where is
Yes.
yours?
Okay, thank you. For those who may not know, then East African community is made of 8 countries, namely Burundi, Rwanda, Kenya, Uganda, Tanzania, Republic Democratic of Congo, DRC, South Sudan, and Somalia. And actually, this community started in the 70s, but it collapsed in 1977. And this collapse actually brought out some new political economic trends. And by that trend, the trade effect were no longer taken as the most important mechanism by which the integration of East African community would be expected to influence development in that region. And then the new East African community after the collapse has been constructed on the basis of the lessons which have been learned from the collapse of 1977. Then now in the East African community, the integration is no more about trade only, but it involves some other areas such as the economic, political, social, also the cultural layers of integration. Then I first look at the potential of East African community as a region to grow economically, but also to become an integrated region. So we have a good climate which favors agriculture and tourism in almost all the 80 countries. There is also a big market involving 80 countries and more than 300 million people who are involved in these countries. There is as well an open, this area is open to the sea in the western part, in the eastern part of the region, which actually favor some exchange in businesses with the rest of the world. And there is also a good reserve of most needed and critical minerals within a good number of these East African community countries. East African community has also high economic potential, and it has been shown in some research which have already been done, particularly the study done by Junichi Goto, who is a Japanese scholar, who tried to use microeconomic indicators to see how the economic potential of this region is. And actually, he came to some interesting conclusions that interdependency among countries in East Africa is very strong, and in comparison with some countries such as Asian countries. And that he showed that the microeconomical links among East African countries are also strong, and the degree of confluence in macroeconomic variables such as growth, exchange rate, and inflation is also high. These are some of the indicators which shows actually this region have a high potential to grow economically, and also it is an area where actually businesses can be grown. But then the main question is how then can this region realize its economic potential? Here I focus on some of governance issues, which will some element in the government which will do promote this process of integration with this region. And here I found that to promote a more pragmatic and the less rigid cooperation model is one of the key elements which would help this region to be more and more integrated. And I found that there are two essential principles which would be promoted in order to promote the integration with religion. The first principle is the principle of variable geometry, and the second one is the principle of subsidiarity. And these two principles, if applied within the governance and the decision processes with religion, can be help to define some functions of the power in various layers of the regional cooperation. And what does it mean? The principle of variable geometry. The principle of variable geometry allows integration to proceed in steps, and at the same time allowing smaller subgroups to move faster than the whole group, while providing that many decisions be made by the majority rather than by consensus. And here it has been actually realized that these countries, even though they are in the same common region, they are not moving at the same level. And actually, this principle of variable geometry may allow some countries who may be going faster in integrating some principles and the protocols to go on their own rhythm, and others to allow them to go in more slowly, but at the same time trying to integrate the whole process. And the principle of subsidiarity provide the basis for distributing powers and the responsibilities across the several layers. And here we consider they are from the national level to the regional level of this organizational structure of the regional integration scheme, and according to the comparative advantage in each in respect of different functions. And actually now this at the level of decision making, this is also very important because this principle allows actually people involved in these countries to have a say in the decision which are being made at the governance level. Then here, there are some added values which this model based on these two principles may bring out. And this there will be a model of cooperation which gives room to coordinate the national initiatives. Actually, there is an increase on the democratic values, which may come with actually this kind of model of cooperation. East African community is as well claimed to be a people-centered organization. And here we refer to the Treaty of 1999. And but this domain needed to be much improved in order actually to externalize this value, because it seems in the protocols and the way the community is moving, there is a much needed advancement at this level. And what may be considered as a way forward? There is a need of harmonization of rules, norms, standard, and procedure in line with the signing protocol and the treaties. Here it has been noted that actually countries are not moving at the same standard in actually implementing rules and the norms and the protocols which are signed among these countries. And actually, as an example, there is a free visa which has been decided in the protocol of free movement of people, but in some countries, when people move from one country to another, they still need a visa. And while this has been removed more than 2 years ago. And there is some other concerns about the labor policy as well, and the various policies from the East African community, like in some countries, the protocol of free movement of people and the labor allows people to go to work in another country without necessarily needing a work permit. But in some, this protocol is not applied at the same level in all countries. In some countries, we find that they still need the work permit. In others, it is not a requirement. And there is no standard which is applied in all these countries. And this also may need to be normalized. And what may be the role of external partners in promoting economic growth and development within the East African community? Well, on one hand, they need to build strong economic partnerships which may go beyond some small trade arrangement in order to build partnerships which are stronger and which will be based on win values. Secondly, partners may help East African community to be more integrated into global economy, like facilitating some exchanges between European Union, for instance, and East African community countries or country members. Also, there may be some facilitation at the level of promoting and facilitating EU investors to come actually to do to make some investment within this region. And actually, this also may be one of the foundations of promoting economic growth and development. As a way of conclusion, there are as well some other values which will need to be promoted in order to promote economic growth and development, particularly the issue of peace, because we have within the region some challenges of insecurity and the lack of peace in some part of this region, like in the eastern part of Congo, like in Somalia. The issue of peace needs to be promoted, and finding appropriate measures on promoting peace and the cooperation, proper cooperation among country members at this level. Another issue is breaking the treaty protocols and the regulatory norms and their enforcement among the member states in order to make sure that there are some standard and the normalized level of applying protocols which has been decided within the community. And then lastly, there is valuing and promoting external economic partnerships. And this is one of the key areas member states may need to work together in order to find a common ground of promoting this strategy. I thank you for your attention. Thank you.
Thank you, dear Desira. Thank you very much for your insightful and engaging presentation. Okay, are there any questions or comments from you?
Yes, I have a question, if it's possible.
Okay, please.
Dear colleagues, thank you for the interesting presentation. I would like to ask, do you have some national initiatives in the area of ecological issues like environmental problems, something like that?
Sorry, I didn't rightly get there is some echoes. I didn't get
you told that national initiatives is very important in resolution a lot of problems, for example, like according to democracy, policy, and I'm just asking if you have some national initiatives in the area of environmental issues. For example, if I don't know if in your country you have some national initiatives in this area about
environment, issue of environment.
Yes.
Yes, indeed. The issue of environment is very important within the East African community, but actually we do not actually have any protocol in this area. But there are some areas which are emphasized are the union of the market, the common currency, and the political integration. But these are actually the layers, like the area of environment, are the layers which are promoted by the civil society. But at the protocol level, there is no clear protocol on that. But the country members are acting on a local level.
I understood. But important that you trying to provide this. So I'm sure that implementation of those initiatives will have positive effect. Thank you.
Okay, thank you too.
Okay. Professor, I have a question too.
Yes,
Okay.
please.
A short question. What main strategies do you think EAC, East of Africa, is focusing on beyond trade its regional integration efforts? Beyond trade.
Okay. Sorry, I didn't catch.
What is the main strategies?
The
What
main
is the main
strategy is to promote a
strategies?
trade.
Yes, in its regional integrations efforts.
Yes.
Okay.
The main strategy is to promote a trade among the country members was actually to remove taxes on a product which have been made inside of each of the countries. So there is a kind of a free trade without any taxation for any product which is made within any of the country member. So this actually has been facilitating like the process of industrialization and promoting cooperation at the level of business exchanges.
Okay, thank you very much. Thank you again. Dear Ludmila, are you able?
Yes, yes.
Okay, I would like to invite Professor Ludmila Smrko, Ujor National University in Ukraine and Coimbra University in Portugal. Dear Professor, the floor is yours.
Thank you. Oh, just a moment. I have some problems with sharing the screen. I'm sorry, did you allow me to share?
Now, there is no data in screen. Please click on your share icon. The right of screen.
Yes. No, okay. Just a moment. Is my presentation visible now?
Yes, we see it.
Yes.
It's okay? Great. Dear colleagues, first of all, thank you very much for the invitation. And it's my pleasure to share our results of our research. And today I would like to talk about sustainable energy from organic waste. I will present results of case study of biogas production. Global mushroom production increased from 32.9 million tons in 2020 to 38,000.3 million tons in 2022. And driving by a growing demand for nutritious food options. So edible mushrooms are greatly appreciated for their high level of protein, fiber, vitamins, minerals, and making them an attractive alternative food source. And additionally, they are rich in bioactive compounds with anti-cancer, antioxidant, and anti-diabetic properties. Actually, mushroom cultivation generates significant amount of spent mushroom substrate, SMS, with approximately 5 kilograms of SMS produced for every 1 kilogram of mushrooms harvested. So historically, this byproduct has been discharged as waste, contributing to the environmental challenges. But however, those spent mushroom substrate is rich in organic matter, and essential minerals, and also stimulating research in sustainable methods for its recycling and valorization. And the current application range from its use as a fertilizer. It's also used as a soil bioremediation agent and as a feedstock for biofuel production. The findings of this study have important implications for stakeholders, particularly in the following ways. So, spent mushroom substrate as a viable biogas feedstock, research shows that SMS can serve as an effective alternative to conventional biogas feedstocks and providing a foundation for innovative technology development. Dual sector benefits. So mushroom producers gain practical strategies for efficient waste management, while the biogas industry gains access to a sustainable and novel feedstock source. And third is advancing sustainability goals. So this work contributes to ongoing research on organic waste valorization and renewable energy systems, in line with global efforts to promote circular economy. I would like to talk a little bit materials and methods. So on first stage, we prepared a spent mushroom substrate. Spent mushroom substrate was collected at the end of fruiting cycle of the edible mushrooms, such as shiitake and various oyster mushrooms, varieties like gray, yellow, pink, king mushrooms, in blocks 20 centimeters on 10 centimeters and 15 centimeters, with an average weight 1.3 kilogram of each. The substrate consists of aged beech sawdust, approximately 70%, and mix it with cereals such as corn, barley, crushed sunflower seeds, and wheat bran. So here you can see how it looks, this spent mushroom substrate. So to ensure uniform fermentation and to prevent the development and spread of mold fungi, the pellets were regularly aerated by turning them over every 3 days. And on those days, the internal temperature, humidity, and acidity were also measured. So internal temperature was maintained with the range approximately 60 degrees, and measured humidity approximately 65%, and pH was between 4 and 4.5. Next stage was sample preparation. For further research, test sample was divided into 3 subsamples to examine whether the visual differences in fungal micellar inclusions could affect fermentation performance and consequently biogas production. So here you can see on this slide 3 different subsamples. Sample 1, SMS, with the lowest visual content of fungal micellar inclusions, without the visible presence on the surface, but the presence in the thickness of the sample. Sample 2, as you can see, SMS with the highest visual content of white, yellowish fungal micellar inclusions. And sample 3, SMS with the highest visual content of turquoise greenish fungal micellar inclusions. Our next stage was determination of total solids and volatile solids in spent mushroom substrate samples. So volatile solids measure the total organic matter content on the feedstock and often used to assess specific biogas yield and biogas production. And of course, this measurement is essential, and assessing the effectiveness of anaerobic digestion process carried out with those 3 subsamples of spent mushroom substrate. A gravimetric method was used to determine TC content in the spent mushroom substrate, an average sample in which all fungal inclusions were visually identified, and was weighed and placed in a drying oven and set at temperature 105 degrees, where actually it was dried to a constant mass. And the dry residue was weighed, and the TSA content was determined from the ratio of this value to the initial weight of the sample. The ASH method was used to determine the VC content of the SMS, and the dry residue obtained during the determination of TC was placed in muffle furnace and set temperature 550 degrees, where it was burned until constant ash mass was obtained. After cooling, to avoid absorbing moisture from the air, the ash obtained was weighed, and the DC were calculated subtracting the raw ash content from the dry residues and dividing by the weight of the dry residue. The next stage of our study was digestion of spent mushroom substrate samples for biogas production. To evaluate the biochemical potential for biogas production, the three subsamples that which I described before were introduced separately into reactors, and each with one repetition and resulting in a total of 3 repetitions for the substrate sample. Here you can see schematically reactor. So how was this process realized? And for the study of three separate subsamples, a periodic mesophilic fermentation regime at temperature 36 degrees was chosen with the initial average concentration of organic matter of the substrate mixed with the inoculum. So a fermentation period of experimental mixtures was 38 days. And as inoculum, they use organic suspension containing a starting population of methane-generating consortium of bacteria and archaea, capable of restoring metabolic activity when the fresh substrate was introduced. And the consumption of the mixtures used in the performed experiment is given in this table. So here you can see mixtures of the 3 subsamples with inoculum, weight of those subsamples, and starting concentration of subsample in the reactor. Our results, cumulative biogas yield. Cumulative biogas yield during the fermentation of the 3 substrate subsamples is shown in this figure for the 38 days. And biogas production volumes measured during the experiments were corrected to the standard conditions of pressure and temperature. So we had pressure 101.325 kilopascal, and temperature was 273.15 degrees by Kelvin. And here you can see cumulative biogas yield is presented per kilogram OVC in the SMS sample. So here we have subsample 1, subsample 2, and subsample 3. And as we can see, the highest results we got with subsample 2. The final results in terms of cumulative yield of biogas and methane from spent mushroom substrate during the mesophilic fermentation shown in table 2. Both biogas and methane volume output indicators were corrected to standard conditions, as I told before. And the content of methane in the biogas at the end of experiments also we can see here. So the highest percentage of methane was at the end of process of fermentation subsample 2, 69.9. But generally, medium value was 66.2% of methane. So it's quite very high productivity. And of course, we know that plant residues such as corn silage, straw grain silage meth, and grass silage present comparable performance concerning biogas production. But however, SMS offers several advantages such as its availability, its composition, and its processing. So in fact, spent mushroom substrate is a byproduct generated in large quantities and often considered as a waste, so readily available in mushroom cultivation industries. And here, if we will compare average cumulative methane, so we see that spent mushroom substrate is on the first place. And after going corn silage, straw grain silage meth, grass silage, and so on. So our conclusions. The study conducted to evaluate the potential of reusing SMS as a feedstock for biogas production developed promising results. Experiments of anaerobic digestion were performed using SMS directly without pretreatment and the mesophilic regime over a period of 38 days. The results showed that average biogas yield 292 nanometers cubic per ton with a methane concentration of 66.2%, making substrate spent mushroom substrate a strong renewable energy source. So biogas production is most effective during the first 15-20 days of fermentation, after which it decreases. And the spent mushroom substrate is a competitive biogas source compared to the other organic waste materials, as we show in previous table. So its methane yield exceeds that of traditional livestock waste, like cattle manure, poultry manure, and so on. And the use of SMS for biogas production offers significant economic advantage to agricultural and energy sectors, so including cost saving and waste disposal. Also, this approach promotes the development of a circular economy by converting waste into energy, so thereby reducing the environmental pressure associated with import waste management. Thank you very much for your attention, and if you have some questions.
Thank you for sharing such a compelling and insightful presentation, Ludmila. Thank you again. Are there any questions or comments from the participants? Okay. There is no questions. Okay. I want to finish the session.
Yes.
Sorry.
May I know the condition of optimization of the result of your research? What did you find out?
We find
Under
out
which condition do you maximize the outcome?
Thank you very much for your question. Your study is very important in point of waste valorization, first of all. We consider spent mushroom substrate is like a byproduct of process actually in industry of producing of mushrooms. In our case, it was shiitake mushroom. So it's a very interesting study because firstly, we were thinking to use these spent mushroom substrate like manure to improve soil properties, and we also got quite good results. But after we decided, okay, if it's rich for organic substances, we can try use to produce biogas. And as you saw, our results showed that it could be also used for producing of biogas. We got quite good data. And it's very important, like one of the way of waste valorization. It's important for environment, for circular economy to implement such kind of approach in industry. Because I don't know, actually the study was provided in Ukraine. For example, in our country, we have a huge problem with waste. I mean, in all areas of industry. So, and we try to show, even for small enterprises, that it's possible to use those bio-waste products and to get some profit from this. And it's also a huge plus for environment and for economy.
Thank you. Thank you.
Okay.
So,
Thank you again. Okay. The professors here, last of Incohis 2025 Spring Congress. I sincerely thank you all for the valuable insights and excellent presentations you shared with us today. Your contributions have greatly enriched our Congress. I hope to meet you all in person at our next Congress. Okay.
Thank you very much.
thank you.
Bye,
Thank
all
you.
professors.
Thank you.
Bye-bye.
Bye.
Keep in touch.
Thank
Bye.
you.